It seems like nowadays everybody is talking about large language model powered agents. We have frameworks like CrewAI and AutoGen that are making waves in the scene, and everybody wants to know how to develop agents with these frameworks. I've spent a lot of time experimenting with CrewAI and AutoGen, and I've come to the conclusion that it is probably better for you to just build your own custom agent rather than using one of the existing frameworks. So in this video, I'm going to show you how I developed a web search agent. The GitHub code for the agent is going to be available to you. So there'll be a link to the GitHub repository with the source code in the description to this video. If you stick around to the end of the video, I'll also explain to you why I think it's better for you to develop your own custom agent rather than using one of the existing frameworks, especially if you want to build products or put something into production. If you like this content, give the video a thumbs up, comment, tell us about your experience in developing large language model powered agents, share, and subscribe to the channel. Thank you, and let's get into the technical details. Before we dive into the Python code, I want to show you this really simplistic schematic diagram, just showing the architecture of the agent workflow. Okay, so at the top, you've got the overall workflow. Now, what we have is essentially just a web search tool, which I've custom built in Python, and the agents themselves. So there are actually two agents in this workflow. You have a planning agent and an integration agent. For those of you that aren't familiar with how agents work with large language models, you can think of the large language model as the brain of the agent. So it gives it the ability to reason. So the planning agent comes up with a plan to answer a user query. So the user query could be anything, and the planning agent will come up with a plan to answer the user query. It will become more obvious about how the planning agent does this as we step into the Python code. But for now, just understand that this planning agent will output a plan based on a user query that comes in. That plan is then funneled into a web search tool. And the web search tool has some logic and also some function calling in there to enable it to actually take the plan and you run the appropriate web searches based on that plan. The output of the web search tool will be a dictionary that has a URL with the information to answer the query and also some scraped content from that URL. And that goes to the integration agent. Now, the job of the integration agent is to take that dictionary and then decide whether or not the information is sufficient to respond to the user query. And in that case, what it will do is it will create a response to the user query with citations and generate a final response. If the integration agent decides that it's not sufficient to answer the user query, it will provide feedback to the planning agent, who will use that to adjust its plan and then start this process again iteratively. I've set this up so that there is a maximum number of iterations that can happen before a final answer is delivered. And that maximum number of iterations is obviously adjustable. So the iterations will happen based on the maximum number of iterations or whether the integration agent actually just decides before the maximum number of iterations is hit that the output from the web search tool is sufficient to actually respond to the user's query. So it's really simple. I guess the key things you should take away from this is that the workflow has a web search tool and two agents, a planning agent and an integration agent. The planning agent comes up with a plan to answer a user query, which is then funneled into a web search tool to deliver an output to an integration agent, which actually goes on to produce the final response to that query. The other key point to remember is that each of the agents is powered by a large language model, which gives it some reasoning capacity. So that's it. It's quite simple on the surface. We have the agent workflow here. So next, we're going to dive into the code, and hopefully that's going to give you more clarity about how this custom agent actually works. All right, let's dive into the Python code. So I'll start by talking about the setup. Now, the first file I have open here is a requirements.txt, and this is where we put all of the libraries that are needed to make this code run. So we have term color. Term color is a great library in terms of if you've ever worked with CrewAI or AutoGen, you might notice that the agent outputs are color coded. This allows you to print to your command or PowerShell using color. So that's what term color does. PyYAML obviously allows you to handle the YAML files that we have for configuration. The request library. So instead of using the OpenAI client, I'm using the requests and just simply making post requests to OpenAI to use the OpenAI large language model APIs. So I'll be using that with requests rather than using the OpenAI client. You can use the OpenAI client if you want. I just prefer to do it this way around this time. An immutable soup is a useful library for scraping web data. So that's it. It's pretty simple from a library perspective. I would say pretty lightweight as well. The next file that's important here is the configuration file. And this is where we keep our API keys. So we only require 2 API keys for this project, the OpenAI API key and the Serpa Dev API key. And this allows you to actually run a search on the Google search engine. I think it's Google Serpa. So you run a search on a Google search engine and you return a search engine results page, which gives you a headline description of what's on the page, as well as the URL. So that's obviously really useful for building the web search tool. Don't worry, I am going to actually revoke these API keys before this video is released. If you clone this project from the GitHub repository and you want to use it yourself, you should come into the config.yaml and replace these API keys with your own. Next, I'm going to talk through the prompts, and the prompts are a major part in actually getting these agents to work well. So stay tuned for that. Let's walk through the prompting strategy for the agents. So we have 2 prompts. We have one for the planning agent and we have one for the integration agent. If you recall back to the schema that I showed you, remember the planning agent has the job of actually coming up with a plan to answer the user query. And the integration agent's job is to look at the outputs of the search tool and decide whether or not it is suitable to give a response to the user query. So if it's suitable, the integration agent will come up with that response and it will provide a citation. If it's not suitable, it will provide feedback to the planning agent where the planning agent can use that to adjust its plan. So let's walk through the prompts to see how I have implemented this. So starting with the planning agent, you are an AI planning agent working with an integration agent. You have access to specialized tools. When addressing queries, you should follow this 2-step methodology. Step 1, thought. Begin by contemplating the problem thoroughly and devising a plan of action. Step 2, action. Clearly state the inputs you will use with any tools necessary to address the problem. This preparation is essential for executing your plan effectively. You must ensure your plan takes into account any feedback if available. Here are the outputs from the tools you've used. So we have the outputs here. Here is the previous plan. So it's good to give the agent some context about what it's previously done, so it doesn't repeat things that it's previously done. Here's the feedback. And here are the specifications of your tools. So the tool specs is really interesting here because you'll see when I go through the search tool that I've have a dot string at the top explaining the functionality of the tool. So what I've done here is actually allowed that dot string to be read in here, and it gives the agent a better understanding of how to use that search tool. So the last step is continue this process until you've gathered enough information to comprehensively answer the query. So that's pretty simple from the planning agent. Hopefully that's clear. Then we'll move on to the integration agent prompt. You are an AI integration agent working with a planning agent. Your job is to synthesize outputs from the planning agent into a coherent response. You must do this by considering the plan, the outputs from the tools, and the original query. If any information is not sufficient, you should provide feedback to the planning agent to refine the plan. If the information is sufficient, you should provide a comprehensive response to the query with the appropriate citations. Your response to the query must be based on the outputs from the tools. The output of the tool is a dictionary where the key is the URL source of the information and the value is the content of the URL. You should use the source in citation. So there is a small spelling mistake there. Let's just put that in citation, and I'll hit save on that. Here are the outputs from the tool. And here are the plan. Here is the plan from the planning agent. So hopefully that's clear how that works. If you need to inspect this thoroughly for yourself, obviously visit the source code and you can just head to the prompts.py script and you can read this for yourself. Now, I will say these prompts are far from optimized. So you could probably do the same thing in less tokens. And obviously the token usage is important if you are considering anything for production, because you're going to pay per input token. So OpenAI and all other APIs really charge by the million in terms of input tokens. So you want to make sure that the prompts that you use are optimized, essentially getting across the behavior you want to get across the large language model in the least possible amount of tokens. So this is far from optimized. This is something I did over the weekend. So it is far from optimized, and this isn't going to go into production. But for your case, if you are using this, you can experiment with these prompts and see if you can optimize them yourself. All right, so let's get into some of the more serious Python coding elements of this. So we're starting off with a search tool, which you can find in search.py. This function, if you've seen some of my other videos, this might be familiar to you, but all we're doing here is reading in our API keys that we need to utilize to make this search tool work. So that does that automatically for you. It reads in your API keys into environment variables. It's quite handy. So the search tool is actually a class that I've written. And I was describing to you earlier when we were talking through the prompts that I have a doc string describing the class and how it works. And this is really useful for helping the planning agent understand exactly how to use this web search tool. So that's what this doc string is about. You can expect this yourself when you go through the source code. So let's talk about the web search tool. So it's initialized, obviously, first of all, by loading that config.yaml, which has all of the API keys. So we're just setting environment variables here. We have the chat completions endpoint, and that's the endpoint that we're making a request to when we want to use any of the large language models. You'll see why we're doing that later, because we will be using function calling within this search tool. This is all stuff for the requests that we're making to OpenAI. You have the model, so you can select what model you use. And there's this option verbose, so you'll see, because what happens with this search tool is there is the option to print out the results of the searches. So if you turn this off, then you don't get the printouts of the results of the searches. So you'll see that as we go down the class. So the first thing we're doing here is we are generating the searches. So the way this works is actually using a function call. So for those of you that don't know how function calls work, I do have an old video I did on function calling. I also have an article that I wrote on Medium on function calling, so I'll post that in the description to this video. But where function calling is really handy here is that it actually allows us to interact with the output from the agent. So when we get the plan from the planning agent, it's obviously unstructured. It doesn't come in one uniform output, right? It's a plan to follow to be able to get to the answer to the query. What we need to be able to do is take that plan and turn it into search engine queries. So queries we're going to use in our search engine to start finding out that information. And that's where this function call comes in. So you can see here, right, we have the function call outlined or defined. So it's defined in this dictionary. And what we have here is we have a name. So the name of the function that we want to provide the arguments to, which is fetch search results. We have the description of what that function does. So it fetches the search results based on the search query. And then we have the argument, right? And this is the key part. This is kind of where the magic comes in. So what this function call allows you to do is it allows you to take that plan from the planning agent, and it will return the most suitable search query for the plan. So that's it, basically. The function call uses, and if you're not familiar with function calling, you should understand that they actually use large language models to do this, right? So you set this dictionary up, And once you have your plan, so the plan feeds this def generate searches. Once you have your plan, it will actually return to you the search requests or the search queries that are aligned with that plan. And then that can be used downstream in this function, the fetch search results function, to actually go and then return the search engine results page for that search. If that's not clear to you right away, it will become clear to you as soon as I start running an example with this agent workflow. So that's the first instance of kind of using function calling here to help interact with the agent output, which is the plan in this case. So we have our search queries returned, and then we go to get search page. So this is another function call. This function call does something different. So once we've returned our search engine results page, we want to actually decide which page or which URL is the best to visit to answer our question. So the search engine results page actually will return the URL and a description of the search page. So it's like kind of when you visit Google, you search something in Google, you don't just get a URL, but you get also a description there. So it's the same with this search engine results page. We need to decide which page is the best to visit based on that. So I'm using a function call to do that as well. So what happens is it takes the search results as an input, but it also takes the plan and the query. So it gets context of what the plan was, gets context of the search results, and also the query. And then based on that, it will actually choose the best page to visit. So that's the best page to actually visit the URL and then get the information from that page using the scraper. And you'll see that scraper defined later on in the class. So that's what this function call does. So the return is the search queries. That's the result. And then we're doing some formatting here. So that formatting is just, you'll see later when we're actually fetching the search results. So you'll see where that formatting comes in, but it's just to present the results in a way that is readable for us. Okay, so here's where we're actually using the search engine. So we're using the Google Serper dev, right, to that endpoint. So we make a call to the Serper dev endpoint, and that will actually return the search engine results page. So that's just this simple function here. And you'll see that as I run through a real example, you'll see where that search engine results page comes in. Once we have the search engine results page, and then we've run it through that second function call to decide which of those search results is the best to visit, that's where we're actually scraping the website. So we feed the website URL, which will be the best search result to visit. And then we're just using a simple scraper using Beautiful Soup to actually parse the HTML. Now, look, this scraper is rudimentary. It does fail when it comes to certain websites that are rendered, that are written with certain JavaScript, and it doesn't work on PDFs either. So I have put something in there in the prompt to exclude PDFs. However, it will still fail from time to time if you run into a website that is rendered in a certain way that it can't interpret that. So it only works with HTML. So it can parse HTML, but not much else. So it's rudimentary, but just for putting together this quick project, it works well enough. So feel free to adapt this to your needs if you are using the script. So there's our scraping element. And then we move on to the actual putting everything together. So when we put everything together, what we do first is, okay, we will define the web searcher. So we've defined an instance of that web searcher class, and we've set our model. We've defined a model. And then the first thing we want to do is generate the searches. So based on that plan that we received from the planning agent and the query, we'll generate the searches that we want to use on the Serper dev API. And then we'll fetch the search results. So that's using the Serper dev API that I showed you earlier. We'll fetch the search results. So that's based on those search queries. And then we'll use that second function call to get the best search page. So you can see that here, that is that second function call. And we use the search results, the plan, and the query. And then we return a results dictionary. So I think maybe I glossed over this part, but when we actually scrape the website, what we're doing is we're returning a search dictionary. So we're returning a results dictionary. Let me see if I can show you what that looks like here. Just bear with me. Here we go. So we scrape the website and we return that dictionary. So the website URL is the key, and the value is the scraped text from that website. That's the value, clean text, okay? So that's what we return, the results dictionary. So that is the overall output of this tool that we have developed here. So this Python class, this web searcher class, does all of that. So it's really useful because the way it's set up with the function calls enables it to interact with those agents. And at the end, we get a dictionary with the web URL and the content of that website that we scraped. And the useful thing about the URL is it allows us to provide those citations where we need to. Okay, so that's it for the search tool. If you need to run through this in more detail, obviously go and inspect it for yourself in the source code. Just go to the search.py script and it's all there for you. Let's talk through the final part of the Python code, which is the agent class and how we define that. So the agent is, you're going to recognize a lot of similarities between the agent class and the search class at the top. So when we're initializing this agent, so we have a lot of the configurations up here, which are basically just setting us up to make that call to the OpenAI API. There are some additional variables here that we are defining. So the first is temperature. And as you know, temperature can control the creativity of the large language model output. You have max tokens, which controls the number of tokens generated from an output. The tool, so that's the tool that we defined earlier, so the web search tool, and we can read that in. In theory, that tool could be any tool that you want to use, although this agent class hasn't really been set up to be all that general. So you probably need to tweak it a bit to work with other tools. But in theory, that's what that is. That's any tool that you wish to read in to work with this agent class. Now, the tool specs, that is the doc string that is associated with that tool. So you can get that easily by simply getting the dot __doc __ attribute for the tool. And if you've defined your doc string correctly, that should read in as a string to tool specs. And then you've got the two prompts, the planning agent prompt and the integration agent prompt. And we went through those in detail earlier. You've got the model that you define, and then this option to have the output more detailed or less detailed. So this class is quite simple. I think there are only actually 3 methods within this class. You have the run planning agent, the run integration agent, which are quite similar methods. Check response, apologies, there are 4 methods. So check response, which I'll explain what that does in a bit. And then lastly, you have the execute method. So these are the key methods, really. The first 2 methods are simply just putting those prompts into, or making API calls with those prompts to the large language models that sit behind the OpenAI API. So you can see where we're reading our planning agent prompt here, and we're bringing in all of those things that we need to execute that prompt. So we need the output, the plan, the feedback, and the tool specs. And then here is the data payload that we send to the OpenAI API. And you can see here we define our model. This is where the query comes in. So that's the user query. And then under the system, we have the system prompt defined. And that's obviously the planning agent prompt for this run planning agent method. And then we can define temperature and max tokens here. Everything else is pretty much similar to how you would use the OpenAI client, except you're using the request library to post to the URL endpoint. You have your headers defined and your payload, and then you return the response from that running that planning agent. So I won't go through the integration agent because it's practically the same steps. The only exception is the system prompt is obviously using the integration agent prompt rather than the planning agent prompt. Next, we have another function call, and it's called check response. So what this function call does is to act as a failsafe to essentially check the response from the integration agent. When the integration agent comes out with a final response, we check it using this check response, and we want it to meet these criteria. So you can see the argument here is meets requirements, and these are the requirements we have. The response should be relevant to the query. The response should be coherent and well-structured with citations. The response should be comprehensive and address the query in its entirety. So if those criteria are met, we return yes. And if the criteria are not met, we return no. And you'll see the significance of this function call when I get into how we actually execute this agent class. Okay, and I know I didn't mention this earlier, but the function calls, we send the data in almost exactly the same way as we would for just sending a normal chat completion. The only difference here is we specify these two arguments. So tools. So this is our tools dictionary that we specify for the function call. So we need to pass that in to our data payload, and tool choice required, which means that we always want to return this meets requirements. So remember, if you are confused about function calls, you don't quite understand how they work, I will link the video to the instructional video I did on function calls a while back. That will be in the description to this video. And I'll also link an article that I wrote about function calls that should clarify this for you. Now, here is how we actually execute this agent. So the agent actually exists within, the agent is executed through this while loop. So what we have is there's a while loop that has these two conditions: meets requirements, which I just showed you the function call for, and iterations. So let's start with the iterations. What we want to do is we want to continue this process for up to 4 iterations. So after 4 iterations, we will exit this process. The other thing we want to continue is the meets requirements bit. So remember, the final output from the integration agent should meet the requirements that we described earlier. If it doesn't meet this requirement, we will continue to execute this agent workflow. So that's where the significance of the meets requirements lies. It helps us to control the workflow of the agents. So then what we have here is we first generate a plan. So we run the planning agent, and we need the query. Remember, for the first iteration, we don't have an existing plan. We don't have any outputs, and we don't have any feedback. So you can see that is all set up here as none, because those things don't exist for the first iteration. Once we do that, we have a plan that we generate. We can then get an output by using the tool and giving the plan as an argument into the tool, and also the query. So then we generate that output. The output then goes to the integration agent. So we have running in the integration agent here. We pass the query, we pass the plan, and the output. We get a response from the integration agent, then we check if it meets the requirements. So that's doing that function call that I showed you in the previous step. If it meets the requirements, we will exit this while loop. If it doesn't meet the requirements, we will continue on in this while loop. Once we have exited the while loop, we print a final response, and we print that in the color cyan. Just to let you know, I have set it up so we read any query into the PowerShell or the command line with the input statement here. So you'll see that as I run an example in the next portion of this video. We have gone through the Python code for this agent. So let's put the agent to the test, and we'll do it first of all using the GPT 3.5 model. So we'll use 3.5 Turbo. The other thing we'll do is we'll just keep track of the usage of this agent in terms of spend. So I will move over my usage statistics now. So what we have, before I run anything, we have already at $2.16. So just keep track of that number, because we'll track how expensive it is to run this agent. Okay, so we're using 3.5 Turbo. Now let me open my PowerShell, and we can start with a question. To get started with the agent, we'll do Python agent.py run. So now we're being asked to answer your query, right? Now, I have previously used the paper to run multi-op questions to test these agent workflows, especially the ones where I'm using some kind of web search. However, what I realized is some of those questions in that paper were actually wrong. So the answers were incorrect. So what I've done is I'll come up with my own multi-hop question in this video. So I'll do something like this. Let's try, what is the current weather forecast in the city where the next Olympic Games will be held? Okay, let's do something like this. What is the current weather forecast in the city where the next Olympic Games will be held? So this is a multi-hop question because you need to know, first of all, where the next Olympic Games is going to be held, and then you can find out the weather in that place. Okay, so let's see how the agent workflow handles that type of task. So we enter the agent workflow, and you can see the planning agent doing its thing. So it's come up with a thought, and I'll scroll up just to talk through what it's deciding. So to determine the current weather forecast in the city where the next Olympic Games will be held, we first need to identify the location of the next Olympic Games, correct? Once we have that information, we can use the weather forecast tool to check the current weather forecast for that city. Great. So we have an action: identify the city where the next Olympic Games will be held. Use a weather forecasting tool to check the current weather forecast for that city. Okay, so we don't actually have a weather forecasting tool, but that's fine. Let's see what happens. So let's proceed with step one to identify where the next Olympic Games will be held. So we've used our web search tool, and we've got these search engine results. So you can see all of that. These are the search engine results. And then we've got our best page picked out as well. So remember, we set up that function call to identify the best page. And we've got this Olympics.com Paris 2024. So it's obviously selected that as the best page from all the results. So these are our search results, and this is our best page. So it's selected that of all of our search results to find where the next Olympic Games is going to be held. So we visited that page. So remember the dictionary I was talking about? This is the results dictionary we return. You can see the key here as the URL and the value as the information scraped from that page. So then we've got a response from the integration agent. So the next Olympic Games will be held in Paris, France in 2024. Now let's proceed with step two to check the current weather forecast for Paris, France. Based on the information provided, I was unable to find the current weather forecast for Paris, France. I recommend using a reliable weather forecasting website or to check the current conditions in Paris. Great, so that's the feedback we've gotten. Now we're back to the planning agent. I will now use Web Searcher tool to fetch the current weather forecast for Paris, France, where the next Olympic Games will be held in 2024. Let's proceed with this tool to retrieve the weather information. And there you go. We have used the web search tool or the web searcher. So the first thing we do is return the search engine results page, and we've identified the best page to get the weather forecast. So we've got weather.com, weather today, and we have this link. So that's been picked up from the search engine results page. Then we scrape the text from that page. So we have that as the key, we have the weather, and then we have the value as the data from that page. And then we get a response from the integration agent. So we can see we've returned some weather here. We've got a temperature, we have conditions and all of that stuff. And then we get a final response here. And the final response also comes with a source for the weather. So interestingly enough, it didn't provide a source for the Paris part, but that's probably not important in terms of providing a coherent answer. We actually just want a source for the weather. So what we're saying is it's a temperature of 60 degrees Fahrenheit, conditions are cloudy, chance of rain is 44%. Let's just visit the link and make sure we haven't hallucinated this stuff. So I'll bring the link over. And as we can see, Paris, France, we've got 60 degrees, cloudy conditions. Do we have anything on wind speed? Yep, so we've got the wind speed of 7 miles an hour. You can see that here. And we have humidity of 84%. where's the UV index stuff coming in? 1 out of 11 visibility as well, 9 miles. Okay, so it looks like that's actually worked well. And that's just using the GPT 3.5 engine. So that's a multi-hop question that would require you to first go and find out the location of the first Olympic Games, and then the next Olympic Games, and then go and find an accurate source for the weather there. And we've also provided a citation. So this is something that, if you've watched my last videos, I tried to do using AutoGen and CrewAI. So it wasn't exactly the weather question, but I had similar multi-hop questions, and it was a struggle, especially with Crew, to get it to return citations consistently. But using my custom approach, I've been able to get it to return those citations consistently. So let's check the usage on this. So how much this cost us. I'll bring up my OpenAI usage statistics. So we were at $2.16. And it seems we are at $2.17. So I'm just going to refresh because I don't know if this has been updated, but it seems that it hasn't cost us much more. So we're at $2.17. So as you can see, that's the GPT 3.5 turbo use. It's really inexpensive to run this agent workflow. I guess beforehand, I was having to use GPT-4 Turbo when I was running CrewAI, but the CrewAI workflow was around 30 cents to do a similar type of multi-hop question. And I would say the same was probably about the same to do it in AutoGen 2. Okay, so I'm not going to go through any more questions. If you want to play around with this yourself, feel free to clone the library and get it set up on your own machine, and you can play around with it yourself and see how it performs with different types of questions. Just bear in mind that the scraper tool itself is quite primitive. It's really rudimentary. So it will break down if it encounters websites that don't have HTML text that you can just simply pass, right? So you might want to adapt that scraper tool if you wish to be a bit more adventurous with this thing. But other than that, feel free to go ahead and use it and test it and break it and give me some feedback. Tell me in the comments section what you think. I will caveat that this tool that I've built, this custom agent, was just a quick project that I did in about half a day over the weekend. It's by no means meant for production. There's a lot that needs to be done to it to actually make it useful for production, including making sure that the scraper works properly. But it's just an example of how quickly you can actually build one of these things by yourself. So in the next section, I'm going to talk a little bit about why I think building your own custom agent workflow is better than using the likes of AutoGen or CrewAI or anything else. So stick around for that. Okay. I'm going to talk a little bit about why I think that for any kind of agent framework or multi-agent workflow, if you are going to use one, it's probably best to build it yourself, especially if you're looking to build a product or go into production. Now, I just want to caveat that this isn't a kind of scientific, I haven't done any kind of scientific experiments to prove my point. This is my opinion based on my experience developing with both AutoGen and CrewAI and using other frameworks like LangChain, where they have their own React agents in there. I've also used Haystack and I've used Llama Index, which all have some variety of agents that are available for you to use. So on that basis, I want to just get into my opinion here and why I think, custom approach is probably going to be best. The first thing is, when you look at those frameworks, what I've discovered or what I realize is all of those frameworks are built for general purpose agent use. So what happens is you come up with a use case where you want to build a multi-agent workflow, or you just want to use an agent to do something. And you end up having to customize those frameworks a lot anyway, because out of the box, they just don't do certain things that you want them to do. So a good example for me is on citations. I have a lot of work where I need to retrieve information, and it's not good enough to just retrieve that information. I also need to provide a source to where that information has come from. And I found that using any of those frameworks, I've had to implement some custom code to get the citations bit to work. So because they're built for general purpose, a lot of the time for your niche use case, you're going to have to customize them anyway. The second thing is on the prompting. Now, I think when you use these frameworks out of the box, if you don't dig into the GitHub repositories, you won't realize that behind a lot of the agent workflows that you see with Crew, AutoGen, whatever it may be, they've written their own prompts. And if you dig deep enough into GitHub repo, you'll find them. And those prompts are designed to be as general as possible to fit as many different use cases as possible. But the problem is the one size fits all approach doesn't really work when you're trying to build a high quality application. So again, that leads you down the road of customization. You have to dig out those prompts and you have to kind of customize it to use your own prompts. So at this stage, you kind of might as well build your own. If you're having to customize to that level, why not just go and build your own? So those are my first 2 points. They're general, those frameworks, and also the hidden prompts. And those hidden prompts might not be useful for your specific use case. The other thing I found is, I don't know about you, if you've played around with CrewAI or AutoGen and you've managed to get them to work well, let me know in the comments. But I only have managed to get them to work well with GPT-4 models and plus, right? So that's GPT-4 Turbo. And obviously we know that GPT-4o was recently released, but usually it's GPT-4 Turbo that I have to use to get it to work well. Now, granted, that might be because I'm misusing the frameworks. And if that's the case, then, I'll hold my hands up and say, yep, it's me misusing the frameworks. But I think what's more likely is it's somewhere in the middle. It's to do with how the frameworks are set up and maybe how I'm using the frameworks. So yeah, I couldn't get them to work with GPT 3.5, which meant that the costs for running just one query were really expensive. And I've seen this in my comments section. I've had loads of you comment to say that, yeah, you were using AutoGen or you used CrewAI and you racked up lots of costs because you're probably having to use GPT-4 Turbo to get it to work. So the good thing about building your own custom approach is that you can so specialize those prompts and you can kind of specialize the workflow as well. And I'll get onto the workflow bit, that it's likely that your approach is going to work better for your use case because you've designed it specifically for that use case. You've designed the agent workflow, the tools, whatever you're using specifically for your use case. So it's probably more likely to work better with GPT 3.5 than using the general framework. The other thing about those agent frameworks is managing the agent workflow. So this is less so about LangChain, where you're just using a React agent, and more so about AutoGen and CrewAI. So AutoGen recently released capability where you could define a custom workflow. And again, this is moving down the road of customization, you see. But CrewAI gives you 2 options. You can have a sequential workflow for your agents, or you can have this kind of managerial hierarchical workflow, which I used and doesn't work too well. What I found really difficult in both frameworks is to actually implement feedback loops. Now, I haven't used the custom workflow in AutoGen yet, but prior to them releasing the custom workflow, I found it really difficult to implement feedback loops reliably. Building my own custom agent, I was able to implement that feedback loop very easily because, I designed it for that specific purpose to have that feedback loop. And I was in complete control of how the agents operated end to end in that workflow. So you can make arbitrarily complex workflows for yourself if you go down the custom route. And that's my point, really. I think to summarize, you're going to be able to build specialized workflows specifically for your product or for your use case. You can tailor the prompts. It's likely going to be cheaper because you've built it specialized. It's going to be able to do the job that it was meant to do. And, you are able to control the workflow of the agents more effectively because you're building everything from scratch. And it doesn't take that long. It's not that difficult because the high-level APIs supplied to you by OpenAI they're really easy to work with. All you really need is a call to the OpenAI API, and you need some function calling, and that's pretty much it, as I demonstrated in that Python code. The other thing to consider here as well is if you build your own custom workflow, it's pretty easy to then later on down the line, if you want to, you might want to develop this with an open source model. So you can also build that. I think the only challenge with open source model is reliable function calling. Alternatively, you could look at seeing if you can return something in a JSON. But yeah, the reliable function calling bit is the only challenge with open source models. So that's it. If you enjoy this content, subscribe to the channel, give it a thumbs up, comment on your opinion on custom agent workflows, AutoGen, CrewAI, or anything else you've used. Would love to hear your opinions. Thanks for tuning in once again, and I look forward to seeing you on the next video.